So once again, good afternoon all. And today, as yesterday, we were doing velocity time graph, and there we were discussing that how from the velocity time graph we can calculate the acceleration of the body as well as the distance traveled by the body. So last day we discussed about how the acceleration can be calculated, and today from the very same graph we will discuss how the distance traveled by the body also can be calculated. Now, the distance traveled by a uniformly accelerated body indefinitely a certain interval of time is given under the velocity time graph, and how it is possible. So first let us see, just a moment. Yes, in this graph we can yes, we can see over here, just let them, okay, Dipti, Hanshika, Omkar, okay, fine, 6 participants. Okay. Now in this graph you can see the distance traveled by the body during the time interval AC. The time interval is AC. Let me show you again. The time interval is, this is a time interval AC. Okay. During the time interval AC, what is the time interval? T2 minus T1. This stands for T2 and this stands to your T1, the first one, T1. So the time interval AC will be your T2 minus T1. Now the distance travel during this time interval T2 minus T1, what it will be there? It will be it will be half total. See, first 1 minute. Let me bring the graph first so that it is, yes. The area of the triangle, the total distance, what will be the total distance? It will be the area of the rectangle BACE. This is the total rectangle BACE. What will be the area of the rectangle? Length into breadth, AB into AC, and the distance traveled, total distance travels will be the area of the rectangle BACE plus area of the triangle BDE. And how the area of the triangle BDE can be calculated? Half into base into height. So half into base is BE and height is DE. Do you agree? This is the total area. Actually, this is the total area. This area is the total area which is covered. Let me erase it. The total area covered is this area. Okay. This is the total area which is covered by the body. And in this we can see a rectangle BACE is there plus a triangle BDE is there. So area of the rectangle, length into breadth, that is BA into AC, plus the area of the triangle BDE, half into base into height, that is half into BE into DE. Till this is clear to all? You can unmute yourself. I've given you the option, or through the chat box also you can reply. Through the chat box you reply. Okay, fine. Okay, it's coming, yes. Okay. Now see. Now, up till this is clear. And now see, AB, we will replace AC. AC is equals to OC minus OA, OC minus OA. This also yesterday we have discussed. And half into, we will replace BE and DE. We will replace BE by AC because BE and AC both are same. And DE. DE means total CD minus CE. Yes or no? Do you agree or not? Just a moment. participant. Okay, Sandhya. I repeat once again. I mean to say here we are keeping AB as it is. We are replacing AC by what? OC minus OA. BE we are replacing by AC, and DE we can say DE as CD minus CE. Now let us put the values. We know AB is equals to V1, then OC minus OA, that means T2 minus T1, plus half, again AC is coming, T2 minus T1, and CD minus CE, that is V2 minus V1. So with the help of this formula, we can calculate the distance covered by the body. How it is coming? Once again, I'm saying S, that is, we are replacing AB as V1. We are replacing AC with T2 minus T1. We are replacing again AC by V1. This AC, T2 minus T1, and CD minus CE, that is V2 minus V1. Is it clear to all? Student, yesterday and today's, both the notes I will post togetherly. Okay. That's why yesterday I have not posted. Both the 2 days work I will be posting. Till this is clear to all? Okay, in the chat box I'm watching. Okay, fine. Okay. Yes, I got the reply. Okay. Now, after this, yes. After these students come the three equation of motion. Student, be very careful. The equation of motion derivation is not there. Only the equation of motion, the three equations are there. Now, when a body moves in a straight line with a uniform acceleration, we can establish a relationship between the velocity of the body, the acceleration of the body, and the distance traveled by the body in a particular time by three equations. What are these? V is equals to, what are the, let me highlight it. What are the three equations? The equation is, just let me use the V is equals to U plus AT, where V is the final velocity, U is the initial velocity, A is the acceleration, and T is the time taken. S, distance covered, is equals to UT. That means initial velocity into time plus half AT square, half into acceleration into time. And V square minus U square is equals to 2AS. V square minus U square is equals to 2AS. That means the final velocity minus the initial velocity is equals to 2 into acceleration into the distance traveled. Now, equation 1, V is equals to U plus AT. This gives us the velocity time relation. The equation 2, just a minute. Equation 2 equation 2, this equation 2 represents the position time relation. Be careful. Whenever the question will be asked, what is a velocity time relation? We have to indicate equation 1. When it is given the position time relation, we have to indicate equation 2. Okay. And when it is given the position velocity relation, then we have to indicate the equation 3. Okay, this equation. Now, we can derive the three equations by the graphical method, but remember the derivations are not, in the latest edition, the derivation has been deleted. Okay. So these are the three equations of motion. We have to remember this meticulously. Why? Because when we will do the numericals, we will apply all the equations. Okay. Next, we will be coming to the topic of uniform, or we can say the last topic of the chapter, that is uniform circular motion. Okay, uniform circular motion. Now, what is first a uniform circular motion? When a body travels equal distances in equal interval of time, okay, over a circular path, its speed is uniform, and the motion of the body is said to be uniform circular motion. The direction of the motion at any instant of time is along the tangent to the circular path. This I will be telling you how it is happening. Now, see student, first of all, to understand this uniform circular motion, let us see first. Let us first consider the, just a moment. Just a moment. Now, yes, my screen is visible now. My screen is visible to all. Just once you reply me through the chat box. Once you reply me through the chat box. Okay. Okay, fine. Now see, let us first see figure A. Okay. It is a rectangular track A, B, C, D. Now, suppose the athlete change its direction of motion at the four corners A, B, C, D of the rectangular track in every round. What the athlete is doing, first see, A, athlete is moving from A to B, then B to C, then C to D, and then D to E. Now, in the second figure, okay, in the second figure, you will show this is a rectangular path. In the second figure, it is a hexagonal path. And in every round, the direction of the motion is changed at how many corner in a hexagonal. Suppose I am talking about a rectangular track. So in how many corner the athlete can change its direction? If it is a rectangular track. Okay, Dipti, you can unmute yourself. If it is a rectangular track, Dipti, at how many corners the athlete can change its direction?
Sir, 4.
Okay, very good. Okay, now next question to Soumya. Soumya, unmute yourself. Soumya, unmute yourself.
Yes, sir.
Yes, Soumya. In figure B, which is a hexagonal path, at how many corners an athlete while moving through a hexagonal path can change its direction of motion?
Sir, 6.
Very good. At the point A, 1, 2, 3, D, E, F. So A, B, C, D, E, F at the 6 corners. Now see, in figure C, it is a rectangular octagon. Okay, rectangular octagon, and at every corner the athlete has to change the direction of motion at the 8 corners. A, B, C, D, E, F, G, and H. Total 8 corners. Now, why we are using this? We observe that as the number of the sides of the track is increasing, the athlete has to take more and more number of turns. Okay, if we go on increasing the number of sides indefinitely, we will definitely find now we are getting a shape of a circle. Okay, are you getting my point? First four corners, then 6 corners, then 8 corners, then 10. Like this we are going on increasing. So ultimately we will see the shape has achieved where it is nearly the shape of a circle. Now the length of each side, then it will be 10 to 0 because now it is a circle. Along the circle, the athlete has to change its direction at each point. Therefore, the effective direction of the motion is along the tangent to the circular path. We have to draw the tangent. Okay, tangent is 90 degree to the particular point. Okay. So this is the case of a uniform circular motion. Now here we can also calculate the speed. Speed is equals to distance by time taken. And what will be the distance for one complete revolution? For one complete revolution, definitely that will be the circumference of the circle. And the circumference of the circle we know as 2 pi r. So 2 pi r is the distance traveled divided by the time taken. So here the formula arises. Yes, Dipti. Okay, okay. Yes, I have seen your query. See, these are the tangents. Dipti and Soumya. See, at at this point, the direction of the motion is 90 degree. Okay. At this point, the direction of the motion is tangent. That means it is going in this direction, which is 90 degree. Is it clear to all? Suppose all the points are not possible. All the points are not possible. So at this point, it is going in this way. At this point, it is going in this way. So these are the tangents. Okay. I think this was a query of Dipti and Soumya. Dipti and Soumya, is it clear? Okay. Now see. So this is the speed. Speed is equals to 2 pi r by t. For example, let us see some of the examples of a uniform circular motion. And some of the example are, suppose a piece of the stone tied to a thread and rotated in a circle with a uniform. If you'll hold a piece of a stone, okay, with a thread and then round and round, keeping it as a center at position. So this is an example of the uniform circulated motion. You can see over here the direction also, that if the stone is there, the stone is rotated in this direction, and hence even the motion of the earth around the sun is also a uniform circular motion. And if we are saying a cyclist moving uniformly over a circular track, if it is a circular track, a cyclist is moving, then it execute a uniform circular motion. Is it clear to all? Is it clear to all? Okay, through the chat box. So let us have an overview of the chapter, because the chapter is completed, and in our next classes we will be doing the numericals also. So let me ask the questions, and whosoever want to answer it will raise your hand and I will unmute you. First of all, what do you mean by a motion of an object? What do you mean by motion of an object? What do you mean by motion of an object? Okay, Dipti raised her hand. Okay, Dipti, unmute yourself.
Yes, sir.
Yes, Dipti, go ahead. What do you mean by motion of an object?
Yes, sir. Sir, an object is said to be in motion when it changes its position with respect to time.
Okay, well said, Dipti. When an object changes position with respect to time. Okay. My next question, what do you mean by a reference point? What do you mean by a reference point? This, apart from Dipti, I want all the student one by one, you should participate. What is a reference? Okay, Omkar. Om Kumar, sorry. Om Kumar. Yes, Om Kumar, you can unmute yourself.
The point from which we describe the motion of body.
The point from which we describe, okay, yes, so the reference point, or the point from where we say that motion has started. Okay, good. Om Kumar, very good. Next, okay, what is the distance traveled by a body? What is the distance traveled by a body? What is a distance traveled by a body? Just raise your hand. Okay, Rudra. Rudra, unmute yourself, Rudra.
Yes, sir.
Tell me, Rudra.
The
What do you
actual path or length traveled by a body during its journey.
Okay, okay, fine. Good, Rudra. Now we will be coming to the next concept, that is a displacement. Okay, Sandhya. Sandhya, what is displacement, Sandhya? What is displacement, Sandhya? Sandhya, what do you mean by displacement? You can unmute yourself, Sandhya. Yes, Sandhya. Okay, I think some network issue. Okay, Dipti again raised her hand. Dipti, unmute yourself.
Yes, sir.
Yes, Dipti.
Yes, sir. Sir, displacement is the shortest path or length between initial position and final position of an object, and it is a vector quantity as it has both magnitude as well as direction.
Okay, Dipti, your last day query, one of the query was related to displacement. Okay, I think you have
Yes,
asked that why the displacement is negative. Was
yes,
this
sir.
your question?
Yes, sir.
This,
How can be the displacement be negative?
okay, displacement definitely, Dipti. Okay, just a moment. You see over here, the when the final position of an object in motion coincide with the initial position, the displacement will be zero because that time there is no shifting. Okay, but the distance traveled is not zero because from one point to the next point and from next to the previous point it is coming back. So the distance traveled is not zero. But when the distance traveled is zero, the object may be at rest. And therefore, we will be saying that the displacement would also be zero. But the displacement can be negative. Why? Because when the final position of the body, yes, Dipti, you have raised your hand. Do you want to say anything? Dipti, you want to say anything? You have raised your hand again.
No, sir.
Okay. Okay, so why it is saying? We are saying because the displacement is zero. When the final position of the body is coinciding with the initial position, that means the body is starting again coming back to the its initial position. That time the displacement is zero. Got it? And we know that how the magnitude of the displacement can be calculated. Yesterday, not yesterday, day before yesterday, in the other classes also we have done. So in that case, we will be saying that the displacement of the object can be positive, even it can be negative, or even it can be uh, zero also. Okay, let me ask one question to Rudra. Rudra, at what case we will be saying the displacement will be positive? How it is happening? Rudra,
When the object is traveling in one direction.
object is traveling in one direction. Yes, correct. And when it will be negative? When it is traveling in, yes, Rudra?
The opposite direction.
Opposite direction. Yes, correct. That time it will be the negative one. Okay. Yes. When the direction of the motion changes, that time it is a reverse one. Is it clear now to all? Acha, Dipti, is your doubt is clear now? When it will be 0, when it will be positive, and when it will be negative?
Yes, sir. Now clear.
Okay. Now, yes. Now, next question to, just wait a minute. Now, let me ask you from the distance time graph. Okay, before going into that, one question to all. Speed and velocity. What is the difference between the speed and velocity? Om Kumar, this question to you. What is the difference between speed and velocity?
Speed of a body is defined as the length of part covered per unit time.
And what is the velocity?
Change in displacement of a body in a given time.
Change in
Interval
the
of time.
travel of time. Among speed and velocity, okay, this question to Dipti. Dipti, among speed and velocity, which is a scalar and which is a vector quantity?
The speed is a scalar quantity and velocity is the vector quantity.
Velocity is a vector quantity. Okay. Okay, next question to Soumya. Soumya, you can unmute yourself. Soumya, how average velocity can be calculated? How average velocity can be calculated?
The average velocity equal to total distance by time taken.
Total distance by time taken? See, Soumya, this is the total distance. Average velocity we are asking. It is an arithmetic mean of the initial and the final velocity divided by 2. Okay?
Yes, sir.
Okay. Now, next question to, I think now Sandhya has again rejoined. Sandhya, you can unmute yourself, Sandhya. Sandhya, can you tell me what is
Yes, sir.
acceleration? What is acceleration? Say, Sandhya, what is acceleration?
When the velocity of a body is increased, the body is said to be in acceleration.
Okay. A graph is plotted over here. It is a distance time graph. What is the name of the case over here? What is the name of the case over here in this graph? You raise your hand. A graph is plotted. A graph is highlighted on your screen. Figure 1.8. It is a distance time graph. Okay. Rudra first. Okay, Rudra. What is the case over here, Rudra?
That
First,
the body is at rest.
okay, the body is at rest. Okay. Dipti, you will be saying the second graph. What is the case over here, Dipti? It is a distance time graph.
Yes,
What is the
sir.
case in this?
Sir, when the body is in uniform motion.
When the body is in uniform motion. Okay, very good. Okay. Okay, so now, yes, now it's almost clear to you all, the things. Now remember, student, today's assignment for you all will be, you will memorize all the formulas so that the next very day when we will be doing the numerical, so it won't be a problem for you all. Okay.